So we have Erin Mirsky, who is our VP for digital. She is going to be joining us and leading the healthcare panel. So sorry for the confusion right there, but we'll kick it off here, and she's going to do a great job. Thanks.
Good morning, everyone. I'm Erin Mirsky, and I'm Vice President for Digital Services at Government CIO. And for the next 30 minutes, our panel will address questions and discuss progress they're seeing related to artificial intelligence and machine learning supporting the health issues that they're facing today in their organizations. This group is going to be prepared to discuss clinical issues, regulatory science, and some cyber topics. So joining us this morning is Rosalie Bright from the FDA, George Chambers from HHS, Suzanne Palmer from Johns Hopkins University Applied Physics Lab, and Dr. Rucker from ONC. So I spent a little time getting to know each of our panelists, and I'm excited for them to share the efforts that they're supporting. This is a really great group. And since some of you who know me know that I'm a little bit competitive, if you guys would use the hashtag that we have today for CXO Tech Forum, I'd love to see your comments afterwards. Don't be shy. And so now if each of you would briefly describe your role in your organization, and then we'll begin our discussion, followed by time for audience questions.
Hi, so I'm in the Office of the Commissioner, and within that, in the Office of the Chief Scientist. I'm an epidemiologist, and I have my own research project, but I also kind of get an overview of what's going on in the different product centers, and I represent FDA on the Federal Health IT Research and Development Interagency Working Group.
Great, and thank you for inviting me. George Chambers. I'm Deputy CIO for HHS. That's the corporate side of the house. So we're represented by ONC and FDA, which is great. Thank you, both colleagues, for being here. I have responsibility on the operations side, so I may be a sort of an outlier in this group. I manage the corporate network as well as all the seats for the Office of the Secretary in headquarters, which is about 12,000 seats. We take care of all their infrastructure. And we also have support for cybersecurity and other aspects. So I'll be bringing a different slant to the conversation.
Good morning. I'm Suzanne Palmer from the Johns Hopkins Applied Physics Laboratory. And just to make sure I clarify our role in the broader Johns Hopkins organization, of course, we are part of the university, but we're what's known as a university-affiliated research center, which many of you may be familiar with. So our role is really providing trusted, objective, technical support to the government. And we work in areas that span space systems, where we build, deploy, and launch systems that go to Pluto and the Sun, and I oversee our mission focused on health and healthcare. So that's my role at APL.
Okay, Don Rucker, so we're not quite to Pluto. The Office of the National Coordinator is set up to basically encourage electronic medical records. It's a staff agency within Health and Human Services, as George mentioned, and we have sort of a dual role. On the one hand, we are a regulatory body certifying electronic health records, so involved in a lot of the technology stack, just does it work? And on the other hand, we're there, frankly, to encourage the use of these records, and we do a lot of that with CMS.
Great. So just a quick reminder that following this panel, we're going to have time for networking. And so if people in the back could keep the chatter down, because it really does, we can really hear you up here. So it does get hard to hear. And so our first question for you guys, over the last 50 years, AI and healthcare have been a popular topic among researchers. It's not new. And we're currently seeing an AI renaissance. And it's fueled by deep learning algorithms, investments that we're seeing in precision medicine, robotics, imaging, and diagnosis. How is this resurgence different from the past? And how do we avoid some of the trappings? I love the irrational exuberance that Dr. Cott and Molly Kane mentioned. So how is this different? And we'll start with you, Dr. Ruckers.
Yeah, so depending on how you look at the perspective of getting older, I had the privilege of being a grad student in the first AI revolution. So I was a grad student in the medical computing group in Stanford's AI lab in the 80s. With my thesis advisor was Ted Shortliff, who invented rule-based expert systems. And I think what's different now, or maybe even in the early 90s, when we had neural nets, I mean, looking at those early projects, you just intuitively knew while they could certainly solve some problems that hadn't been solved, they were really, in many ways, toy systems, right? If the premise of AI is to be like the brain, right, just the overall premise, and the brain has something 10 to the 10th neurons, 10 to the 13th connections, having a few hundred nodes in a neural network is very unlikely to represent the brain on any level. And so we frankly did not have the resources. I mean, these were the days when we weren't even up to, a meg of memory in the early Windows operating systems. So we were trying to do this on essentially negligible amounts of computing. Today, we have vast amounts of computing. And I think when you look at machine learning, when you look at the algorithms, when you look at the representations, there's just vastly more compute power, and it can give a lot more accuracy in the model. So it's very exciting, and I think we're seeing the performance you would expect. So it's quite exciting.
Yeah, so I completely agree. It's funny, when I entered the workforce, as my kids like to remind me, in the 1900s, it was signal processing, right? And so in the days of signal processing, it was really, in a lot of cases, you had a two-class problem and you were trying to separate signal from noise. I think today, as we look at, of course, the increased compute capacity, but also measurement, and as a result of measurement, the amount of data that we have available. So not only are we able to measure many more things with many different modalities, but we're able to measure it to levels of resolution that we could never achieve before. And so when you look at all the data that's available to us now to use as input into these, whether they're neural nets or different approaches, deep learning for artificial intelligence, I see a huge shift. We're able to ask questions beyond, yes/no questions. Is this a target? Is it not? Is it, disease state? Is it not? But you're able to look across varying complexity and, look at a multi-dimensional state and try to pull out patterns across disparate data sources.
So I'm going to keep moving because so Rosalie, how is big data helping expedite FDA approvals for drug devices, specifically around clinical testing and delivering new cures for pre-certification type programs? And then if George would also talk about how how robotics is impacting the mission. So these two are very related.
Okay, so there's a new pre-certification program that is for devices only. It's just a little bit of a pilot because it's not there's some questions about the statutory authority to even use this model. So right now it's just in a piloting phase where FDA has selected several companies to work with them on how this would work in general. So I see it as kind of an extension of trying out third-party certification from a couple decades ago, but now the idea is, okay, so if a company is mainly just producing software, that's its medical product, can we trust that if they have good processes in place, that they're going to be good actors, that their software is going to be basically reliable and not hurt people unnecessarily? If something is detected as going wrong, they're going to take the initiative to fix it as fast as possible. Can we just basically leave a company like that alone to put things on the market and then just do whatever monitoring this group together is going to come up with as being an appropriate monitoring? But just to say there isn't an explicit statutory authority for this doesn't mean it's a no-go, because there have been a number of instances where, in the past, regulatory-wise, where agency has the agency has done some pilot, and then that has persuaded Congress to give it a full explicit statutory authority. So right now, that's just in the very beginning stages. And as far as using big data for pre-market applications for any kind of product, there is an initiative called Real World Evidence, Real World Data, and to me that's where the big data would come in, and that is still also in the beginning stages of trying to think about, well, when would we think that extending the current use of real world data for supporting randomized clinical trials, that's been our current use for some applications. How are we going to depend on that more? And the agency just released a framework in the past month that talks about what FDA is already comfortable with, what questions they still want to work on for getting answers. And the National Academy of Science, Engineering, and Medicine has published a couple of workshops that are asking the same kind of questions. So they're all still in the beginning phases.
And even on the operational side, we're seeing robotics supporting the mission.
Yeah. I'll jump in. Thank you. As you can tell from the panelists, there is no denial that AI is playing a role in our everyday lives, and it's growing. As a matter of fact, I would consider the prevalence and proliferation of AI, whether it be artificial intelligence as you know it, or more robotics automation or RPA, it becomes part of our fabric. And from my perspective, and probably part of the message of this morning for me, especially in this audience who are all players within the AI environment, is that now that we're deploying AI, and even some of its attributes, the ancillary attributes like visualization, which is once you've got the data, how do you visualize it? All of these provide opportunities from an infrastructure and operational standpoint. Number one, as you see RPA being deployed in major applications, in my view, if you want to just step back a little bit, regardless of the technology, you're introducing somewhat of modular type of activities that have to be managed from a configuration and control standpoint. In other words, I change applications. I have a management process that makes sure, similar to interfaces. So as they proliferate, how am I making sure that my configurations are all still in place, that I've tested it appropriately, and that I could deploy it in a major production environment that have multiple systems, all potentially using these AI in different ways. So the calls, the APIs, all these things now in a proliferated standpoint, very, very similar to APIs. There are no control functions. There's no software tools out there that allow an operational group to manage it all. So it's pretty challenging and interesting, right? And then you also have the same idea that you've taken AI and personalized it. And now I can use some of these visualization tools, I can put them into an application or a data set, and I can start deriving information that may be a different look. The only problem is without good data management and governance, are we sure that we're seeing the data integrity? Is the same data element coming from this database comparable in terminology to this one over here, so I can make those kind of determinations? And AI can help us do that. But once again, these are the challenges from an infrastructure and support standpoint, especially with an organization 88,000 strong, like HHS, in all of our operating divisions. How do you put your arms around, number one, the proliferation and management of all of these technologies that are being introduced, and number two, how do we maintain data management and governance?
Thank you, that's great. One of the areas that is new and most exciting is around unstructured data in our health electronic records. And I'm curious from each of your opinions, how are you seeing different applications and pilots and use cases today that are really impacting disease and diagnostics and advances? We'll start with you, since.
Okay, sure. So some of the work that we've been focused on with our partners at Johns Hopkins Medicine is how to best leverage all the data that is now in the electronic health record, and how do we pull out useful data from the EHR and combine it with other data sets? So things like imaging, genomics data, all kinds of wearable data. How do we make use of the unstructured data that is in electronic health records? And so one of the approaches that we've been focused on is natural language processing. I'm sure lots of people are working in that space. But the focus that we've had is on generalizability. So of course we can develop an algorithm that looks to pull out one piece of data, and you can train it and you can get it working pretty well. But then can you take that same algorithm and with minimal customization have it work against a completely different data set? So for example, the work that we've been doing initially started out focused on prostate cancer. And it was simple things like, can I pull out PSA scores and Gleason scores from unstructured text in the notes section? And of course, we went through and implemented that. But then the clinicians were so excited by the fact that they could have all of this data just automatically populated into other systems that the folks in multiple sclerosis said, well, we'd like some of that. So we started with the base algorithm, and within a couple of weeks, we had it working really well against some of the parameters of critical importance to MS. So that's just one example, but I think across the board, what we're focused on, and again, we're kind of an engineering organization, so we come at the problem from a slightly different perspective, but as we work with our partners on the medical side, how can we develop these algorithms and then have them generalizable beyond one specific disease or one specific condition?
Dr. Rucker?
Yeah. So it's always been an interesting tension between structured data and unstructured data. They have different uses. We are asked all the time as an agency about rules and standards around both of those things. It's worth understanding that if you want to structure data, you have to pay somebody to structure it if it's not coming from a machine. I think the big observation is that you can now actually look at documents as a whole, right? A lot of clinical medicine, right, or what are called notes. So if you look at the core data element, you have some of the machine-generated data, lab tests, images, and then you have this vast body of notes. And so there's two things we've been working on. One is just getting the notes so you can ingest them into a different system, something called the clinical document architecture. The other thing, if you actually look at the notes, what is not maybe immediately obvious if you're not in healthcare is most of the information in notes is actually templated nonsense. So the problem with notes is that they're largely geared as billing documents in America. And that means using a series of AMA, what are called CPT codes, Common Procedural Technology. So working heavily with CMS, we're starting to try to get this documentation to actually reflect what went on with a patient. This is going to be very important because under 21st century cures, and open APIs, you're actually going to have access to the notes. And I'm sure you'd much rather read about something that has to do with you rather than a billing template that was put in on you and the last 1,000 patients and the next 1,000 patients. So there's an interesting NLP problem that's sort of lurking underneath, which is data quality. And of course, that's true of all AI. So we're more on the data quality side because we want to enable this. And this is actually central to getting some handle on healthcare, because if you're going to look for value, we don't have a market economy. We don't buy our healthcare for ourselves. For the most part, we have third parties do it. If you look at how do the third parties do it, it's this search for value. You have lots and lots of people in healthcare policy doing that. What data do they have? So that's really what we're talking about in terms of moving the ocean liner of American healthcare to something more responsive.
Great. So we've talked a little bit about opioid abuse, misuse, and the addiction issue that has become one of the biggest public health crises that we're facing today. It's also very personal for many people. And this requires really innovative approaches. So in May, the FDA launched an innovation challenge focused on advancing pain management devices. But all of you are involved in different challenges and activities in interfacing in your organization and with others. And I think it would be great for you to share more about how these challenges and new ways of doing business are impacting healthcare in your organization. And we'll start with the FDA that launched this initiative.
Okay, so that May initiative was one that was directed at device manufacturers, and are there things you can do to address the opioid crisis? So one of them they selected 8 companies to work with to kind of expedite approval for them. And one of the ideas they picked wasn't really about pain management. It was about how to use the data to flag potentially dangerous opioid prescriptions. So it was fairly wide-ranging. The selectees have just been announced, so we'll see how their experiences are with going forward and working with FDA more closely. Now, I should say, every applicant is encouraged to work with FDA anyway. This challenge just put more of a highlight on that, but we're always telling potential applicants, work with us sooner rather than later, because we can work together to figure out what data you need to submit so that you don't go around generating data that you don't really need to and delay things, and so that you don't submit applications that are missing key pieces of information as far as our reviewers go. So we love having that opportunity.
So HHS, and I'm sure some of my colleagues participated, and probably a number of the people in the audience did, in a Coda THAAD that was sponsored about a year ago in December. I think it was from our CTO organization, my sister organization or brother organization. The CIO and CTO sort of jointly facilitated a 2-day event that was all about bringing small businesses, large companies into a forum where people would have access to data sets and have access to systems. And we were looking to drive a change and some learnings through a Coda THAAD. And I believe we ended up with 3 significant outcomes. I don't know how significant, but reasonable outcomes. One was one of the contestants that ended up being awarded created a heat map that highlighted 5 states where there were a significant number of mortality associated with overdoses. And this is over a 2-day period. The second group were able to identify a mechanism to allow clinics to create a drug return opportunity. So in those particular states, if we could reduce the amount of drug that was out there, i.e. unused pills, and create a channel for getting those brought back to the clinics and disposed of, that was another opportunity. The third was a physician dashboard in which physicians could in fact look at their prescription habits around the opioids and compare those prescription habits to the general prescription habits across the nation. So those were 3 areas in a 2-day period where technology and technologists got together and were able to make a quick impact on a very, very important area.
So I want to chime in on that. I observed the last hour and a half or so of that challenge, and I was there for the presentations of the top groups to become the actual winners. And I was struck by how many teams actually had a person on it who was impacted family or friend-wise. The level of passion was really gratifying.
I'd like to move to the audience for questions. We have time for a few. raise your hand and we'll find you.
Excellent panel. I was wondering, what are current, I guess you say, challenges you guys are seeing that you wish AI or machine learning and different analytics teams would start going after that people currently aren't taking a chance to go after?
Well,
Great question.
I'll answer. I think one very interesting area that we're starting to look at a little bit in HHS, CMS, is as I was discussing, the sort of search for value. So right now, American clinical medicine is incented at the margins through something called quality measures, which are individual, essentially hand-curated metrics, right? And they're very expensive to collect. They're heavily gamed because you're paid on these metrics. So, and they're gameable and they're heavily gamed. And that's the proxy for value and quality of care. I think you can absolutely think about using AI to invert the entire information flow. So rather than doctors and hospitals sending these narrow quality measures to CMS or to private insurers, you could imagine a world using the APIs that are in progress where you reverse the information flow. You have the payers go directly to the electronic record endpoints, download for all the folks where you have a legal right, so everybody you're paying for, download some large set of the data, and then think about using machine learning algorithms to separate out not just who's, quote, better and who's, quote, not better, right? Not just rank ordering people, which is the current payment scheme, but actually identifying possibilities of taking better care of patients. It's a massive opportunity. There's probably all kinds of intermediate states to do it. So if you want a very gnarly goal, I'll throw that out.
Love it.
There may be, this might be a good lead into the next panel, but from an infrastructure standpoint, there's not only a lot of effort going on into self-healing networks and infrastructure through AI, which is predictive analytics saying this server will fail in this time frame based on the attributes that they're seeing in the patterns. And therefore, we can have self-healing networks which reduce your overall costs, and those dollars can move to the mission for opioid crises and things of that nature. But there's also another aspect where AI is being at least entertained, and that's in the cybersecurity realm. Right now, we're very reactive. We have breaches, we react. How AI, with the backdrop, if you're all familiar with the Continuous Diagnostics and Mitigation Program, CDM of DHS, which all of the federal government is a part of, HHS being one of the first of the federal agencies to fully deploy CDM phase 1. The promise there is to create an infrastructure where we can diagnose and mitigate, detect and mitigate cybersecurity threats. And I believe AI is going to play a major role in that ability to not only detect, but counter the bad players. So I think there's an opportunity there, and I think you have a whole discussion topic coming up on that.
I had many other questions, and go ahead.
Oh, please.
One more point.
So another area that I think all of us have heard about is physician dissatisfaction with their electronic health record system. There are a lot of people saying it adds time to their workday, it takes their attention away from their patients. I think coming up with a system where physicians feel like it's part of their right hand, is seamless, is useful for them, and not just the physicians, all the other staff that are involved with putting information in and trying to get information out. That is a huge challenge. I don't know how much AI would play a role in trying to figure out a system that's more user-friendly, but conceivably there could be, but at least it's a need, because until we get really good data that people are happy to put into the records, it's going to be harder to get the really important information out.
So I just want to sincerely thank all of you for your great insight and participating. Sounds like we have a few podcasts to line up for Molly, and I will let Michael transition us.
Okay, absolutely.
Thank
Well, thank you very much. Can we get a round of applause for our health panel? Thank you very much. All right, so we're going to give everybody a quick break, fill up on coffee, get a chance to network a little bit, talk to some of the great folks that are here. We got a great collection, like I said, of different agencies, different companies, as well as different academics. But please come back. We are going to have a great conversation here, presentation on what's going on with NASCAR, and then our national security panel. So we'll be back in about 5 minutes, everybody, all right?